We're going to look at problem number 5, and I've copied it and pasted in at the top, and you can read the problem. This is the same problem we did in class, but there were several people absent, so we're gonna take another look at it. I've got a combination of benzene and hexane flowing in. I've denoted the benzene with a capital B and the hexane with a capital H. And then the mixture over here on the right is an M. And I can look at the volumetric flow rate and put a dot over the letter V to indicate not the volume, but the flow rate of the volume. And I can put that same dot over the M and say that's my flow rate in terms of some mass. We know what that number is because they give it to us. It's 1,700 pounds per hour. So I can write m dot of the mixture coming out is 1,700 pounds per hour. And we know that what goes into the blender is the same number as what comes out of the blender, right? Otherwise, there would be an accumulation in the blender or a draining of the blender. We know that that doesn't happen at steady state. What's going into the blender is the benzene and the hexane. So I can write those quantities as V benzene, the volumetric flow rate of benzene, and the mass flow rate of benzene. We don't know what those numbers are yet, but we can calculate them. And the volumetric flow rate and the mass flow rate of hexane, which I can symbolize with these dots and these subscripts. Now I know that the mass flow rate of the mixture coming out is 1,700 pounds per hour because the problem statement gives us that. I also know that the density of this material is 0.810 grams per milliliter. I know that the mass flow rate, the mass is the density times the volume. Therefore, the mass flow rate is the density times the volume flow rate. I can rearrange that because I know the mass flow rate. What I don't know is the volume flow rate. And I can say that the volume flow rate is the mass flow rate divided by the density. Well, what are those numbers? There's 1,700 pounds mass per hour given to us in the problem, and I need to divide that by the density. So I'm multiplying by the reciprocal of the density, which is the same thing. And I'm doing that because when I do that, I can get my pounds mass to cancel here in the numerator and here in the denominator. And I'm multiplying by the specific gravity, which is just a multiplier of the densities. So now when I look at my units, I have cubic feet in the numerator, and hours in the denominator. So I'm going to get cubic feet per hour. Whip out my calculator, do the math, and I get 33.62 cubic feet per hour. So I'm going to write that here, 33.62 cubic feet per hour. And I know a few other things. I know that since what goes in is equal to what comes out, that must mean that the volumetric flow rate of benzene plus the volumetric flow rate of hexane must equal 33.62. And I also know that the mass flow rate of benzene plus the mass flow rate of hexane has to equal 1,700 pounds per hour. Why? Because what goes in must equal what comes out, and what comes out is right here. That's great. That tells us where we are, and that gives us a path forward. Now let's see here. What can I do with this information? I've got 4 unknowns. I've got VB dot, VH dot, MB dot, and MH dot. And I need to solve for all 4 of those things, which looks like on the surface I can't do it. But actually I can. Now, why can I do this? Because I know I have a way of relating the volumetric flow rate of each component to the mass flow rate of each component. Let's take a look at benzene. I can do the same sort of calculation that I did for the overall flow rate coming out to the individual streams coming in. And I can say that the mass flow rate of benzene going in is equal to V dot of benzene times its specific gravity, really times its density. And what is that number? Well, let's see here. I have, for benzene, I can look this up. This is 0.879, and I'll provide this data to you. That's the specific gravity, times 62.43 pounds mass per cubic foot. All right, so when I multiply the 0.879 times the 62.43, I get 54.88 times VB. So I have a way to relate the mass flow rate of benzene to the volumetric flow rate of benzene. And I can do the same thing for hexane. I can say the mass flow rate of hexane is equal to the volumetric flow rate of hexane times its specific gravity, which is 0.659 times 62.43 pounds per cubic foot, and I get a number that's 41.14 Vm, and I should put dots here, right? These are flow rates. Okay, now I know Mb plus Mh. Well, I know that because I've got this formula right here, I now know Mb and I know Mh. So let's move that up and let's take another look. So if I plug those in, I get 54.88 VB dot plus 41.14 Vm dot, and that's equal to 1700. Now, I also have an expression for VB dot. Where's that? Let's see here. My VB dot is really just 33.62, so I'm going to say VB dot is equal to 33.62 minus VH dot. And that comes just by rearranging this formula here. So I'm going to take this formula here and plug it in right here. So now I have 54.88 times VB. What's VB? 33.62 minus VH dot plus, this is not Vm, that's VH right there, plus 41.14 VH dot, and that's equal to 1700. Well, now I just have one equation with one unknown. And yeah, there's some math here, a little bit of algebra that you learned a number of years ago. And when you solve this, you get VH dot is equal to 10.56 cubic feet per hour. There's one of our unknowns, 10.56 cubic feet per hour. Now, how do I get VB dot? Well, VB dot is just 33.62 minus 10.56, and that gives me 23.06 cubic feet per hour. So now I have my answer for VH, my answer for VB dot. Okay, now I need to go back up and calculate what my mass flow rates are. Well, if I go back up here, I have a formula for my mass. My mass flow rate of benzene is 54.88 times the volumetric flow rate of benzene. Now I know the volumetric flow rate of benzene, so I can say the mass flow rate of benzene is 54.88 times the volumetric flow, which is 23.06. And when I do that math, the mass flow rate of benzene comes out to be 1265 0.6 pounds mass per hour. Almost there. Now, from there, it's relatively straightforward to get the mass flow rate of hexane, because that's equal to 1700 minus the 1265.6. And when I do that, I get 434.4 pounds mass per hour. And now I have all four of my unknowns.